Welcome to the Nursery and Garden Industry Queensland's webinar on water efficiency information resources available to the nursery industry. This webinar is funded by the Queensland Department of Natural Resources, Mines and Energy under the Farm Water Futures project. The Farm Water Futures project provides funding to industry bodies to assist primary producers in improving their water and energy use efficiency. Over a period in excess of 25 years, there have been a range of resources developed by the nursery and garden industry that can be used to help production nurseries improve water use efficiency. Some of these resources are freely available to the industry, either as internet downloads or hard copy resources, while others are only available through industry technical offices. If you have a problem with your irrigation system, maybe you want to upgrade your current system or you're thinking of setting up a new system, where do you go to find out the information you need? Irrigation professionals have a broad range of knowledge when it comes to pipes and pumps, but sometimes they may not understand the specific requirements for nursery production irrigation systems. The resources we're looking at today are meant to give you additional information and a greater understanding of how to set up an efficient irrigation system. There are tools and resources that have been developed specifically for the nursery industry as part of funded projects. These projects have targeted areas requiring more research because the specific information wasn't available. Projects have been done covering such areas as the cost benefits of retrofitting irrigation systems and theoretical and actual sprinkler performance data with a range of different sprinklers. Some of the tools that have been developed as part of the Rural Water Use Efficiency Initiative are a sprinkler selection tool, plant water use database, and drip irrigation performance evaluation. These tools and information are available to industry to use in assisting with the design and use of irrigation systems. The first source for general information on all aspects of water use within production nurseries is the publication Managing Water in Plant Nurseries. This book was first published in 1994 and is currently being updated. This publication looks at water supply and quality, water treatment and disinfestation, irrigation types, irrigation design, maintenance and operation, filtration, pumping, drainage and fertigation. iSpace is a database containing performance data on a range of sprinklers used in the nursery industry. This resource was developed using Rural Water Use Efficiency Initiative funding and built on a previously funded project where sprinkler data was calculated in a modelling program and the theoretical performance of a range of sprinklers, jet sizes, pressures and spacing was made and input into a database. The original report, Evaluation of Irrigation Sprinklers for the Nursery Industry, can be downloaded from the NGIA website under the final reports page that was shown earlier. iSpace takes the database of the modelled results and allows it to be filtered using specific criteria to assist in selecting a sprinkler for a particular situation, enabling the performance of sprinklers to be compared against industry best management practice criteria. And this is an example of a search that has been done. This tool also allows simplified irrigation designs to be generated for growers by technical advisors, and there are plans to enable this to be made accessible to growers for them to make their own selections. It should be noted that the results displayed rely on data collected under perfect operating conditions and then calculated in a computer program. It shouldn't be expected the results will be exactly the same in real-life conditions, but the information obtained can be used to select the best performing sprinklers for a given situation. It should also be noted that this selection tool doesn't take into account all of the factors that are required in selecting sprinklers suited to a particular situation. At the moment, this tool can only be accessed by technical officers, but to give an idea of what it can do, here's an example. To search the database, and here it is before we've put any data into it, we can put in a number of criteria. So if we specify that we want an upright sprinkler on a 5 metre spacing, so we select spacing and then 5 metres with an operating pressure of less than 207 kilopascals, a mean application rate of greater than 10 millimetres, but also a mean application rate that's less than 15 millimetres, with a coefficient of uniformity greater than 90% or 0.9, and a scheduling coefficient of less than 1.3. We put in our search criteria and then we click on search, and that will come up with a short list of sprinklers that meet those criteria that we put in. Then it's a matter of looking through this list and identifying those sprinklers that will give us the best uniformity. So here we've got a MAMCAD 16, looks like it's going to give us the best coefficient of uniformity with an acceptable mean application rate. Equally, the Rondo sprinkler also might be another option. Once we've selected a particular sprinkler that we're interested in, we can highlight that, and then we can put in data on what the dimensions of the area are that we're going to be putting these sprinklers in. So if we make the area 50 metres by 23 metres wide and click on confirm, what this will then do is create this schematic layout of the area, which has all of the specifications that we've put in, but then also the number of sprinklers that are going to be required, what the total flow rate for the area is, what the real spacing is, because at that spacing, in order to have the sprinklers right to the edge of the area, it won't be on a 5 metre by 5 metre spacing, and then it will recalculate what the mean application rate is at that real spacing. So that gives us some basic information on how that system should be set up. The next tool that we'll look at is the dripper evaluation tool. Again, this has only been available to the industry through the Technical Officers Network, and it's used to evaluate the expected performance of a dripper or spray stake configuration. To use this tool, either a dripper or spray stake is selected, then the specifications of the system, container size, flow rate of the emitter, number of arrows per emitter, and number of arrows per container are input. We can input the specifications of the system that we're planning to put these drippers on. So if we make it a 250 millimetre diameter container and we specify a 3 litre per hour dripper with 4 arrows per dripper, and then over here 1 arrow per container, you'll notice that in the green is where the calculated results are. So what this is telling us is that we need to have in that size container 2 arrows per container, and therefore the number of containers per dripper is also 2 because there's 4 arrows on the dripper. But that's going to give us a mean application rate of 30.6 millimetres per hour. So this pops up a warning here that tells us that that application rate is too high. The second warning that we have over here is that if we only have 1 arrow in each container, that there's not going to be sufficient lateral distribution of the water through the media, so consequently there'll be dry areas in the media. That does give us an application rate of 15.3 millimetres per hour, which is satisfactory, but the distribution of water through the container isn't going to be satisfactory. So then we need to go back and make some changes to the way that we've got this configured. If we change the dripper discharge rate to a 2 litre per hour dripper, but still with 4 arrows, you notice that the warning that was in this area has disappeared because it's now less than 25 millimetres per hour mean application rate. And then if we put 2 arrows in each container, that then gets rid of that warning that was there. Another factor to consider when setting up a drip irrigation system is that the flow rate to each of the arrows must be the same. If the flow rate from the dripper isn't sufficient to keep the dripper tube full of water, that means that some arrows will receive more water than others, leading to decreases in uniformity across the area. If we put in a low flow rate there, so say a 1 litre per hour dripper, but still maintain the 4 arrows on that, this will show up as yet another warning that says that we need to change that dripper flow rate. Otherwise the system won't be uniform. But this is showing us that the best setup for this would be to have a 250mm pipe, 2 litre per hour dripper with a 4-way manifold and 2 arrows per container. The spray stake evaluation tools allows the discharge rate of the spray stake to be input and the maximum absorption rate and mean application rate of the system required. This then shows the spray radius the water would have to be applied over to achieve the required mean application rate. So if we have a discharge rate of the spray stake of, say, 26 litres per hour, and our application rate of our growing media we want to have the maximum of 20 millimetres per hour, this then calculates out to give a mean application rate of 20 millimetres per hour, means that the minimum radius that water should be thrown out of, depending on what percentage of a full circle it's irrigating, needs to be this figure here. So if you've got a spray stake that's spraying out in a semicircle, so it's spraying out 50% of its full circle, the radius needs to be 910 millimetres. iPlant is a database of general plant water use for a large range of plants. The idea behind this tool is to enter a plant list and then sort these into high, medium and low water use, enabling plants with similar water uses to be grouped together in a growing area. This tool was developed using data from a range of sources and only gives an approximation of a relative water use for a particular plant. Actual water use will be dependent on plant size, stage of growth and growing environment, but this data is useful in deciding the approximate grouping of plants in growing areas. This is the iPlant input page. You can see over here on the right hand side that there's a list of plants that I've already input in there. To select and input additional plants, over on the left hand side we can pull up a list by simply typing in into the search function up the top here until the particular plant that we want to input appears, and then we simply click on the particular species or cultivar that we're interested in adding and then click on add over here, and that will add that to the list here. Once we've input all of the plants, we can then either print this out as a PDF or save it as a CSV file, and just to show you what the PDF looks like, it will then do this printout where it categorizes each of those plants as either low, medium or a high water use plant, and you can save that to your system and use that later on. It is possible to go back and edit, take plants out of the list, add more plants into the list as required. That's about all for today's webinar. If you have any questions on this webinar or any irrigation efficiency questions, I can be contacted on this phone number and email address. Thanks for watching.